Take 53. What's going on, guys, and welcome back to a brand new video. Today we're going to be talking about databases. Now, if you're like me, you're not lazy. Okay, you're lazy. I'm lazy. I'm lazy when it comes down to databases, because there's so much things you gotta do to actually make it a functional database. Like, we've done this before in my other series, but we never actually went to depth. All we did was create a database, and then from a database, we actually just connected to it, and that is it. That's it. We're just reading and writing. But you gotta think about, like, what if the database goes under? What if the data is corrupted? Or what if something happens to the database? I'm sorry, I'm burping. Oh God. You have to think about these things, because you do need to create clones of your database, instances of your databases, and you gotta do so much more. And yeah, it's just a lot of things. Luckily for us, AWS does have services that we could use that will help us do these things. And when a cloud vendor helps you manage the servers and backups all of your data, this is actually called database as a service, or DBaaS for short. And by having a DBaaS, it lets you focus on the data itself and optimizing retrieval versus configuring failover and managing database engine updates. So if you're migrating an existing application into your AWS, then your database technology has already been chosen for you, either by your development team or by the vendor who created your app. Hopefully the vendor knows what the hell he's doing. So I would actually recommend looking at the AWS data migration service, which can take your on-premise relational database and create a real-time in-sync clone of your database in the cloud, so you can perform a smooth transition from your on-premise data center into AWS. Now, if you're actually building a new application or re-architecturing an existing application, choosing a database provider can be complicated. Whew. Before you start having an internal war with your team members or your manager or whoever, you need to think about the data needs of your app that the application actually needs. I hope you got that. The data. You think about data needs. Okay, I think you understood what I was trying to say. So you should be asking questions like, what kind of data will you be storing? How much data do you currently have? How much data will you write to your database over the period of, let me see, I don't know, 1 hour, maybe 1 hour. How much data will you read? Will you be running a bunch of large queries and reports? What kind of uptime do you need? So you need to ask these higher level questions first, and then design a database solution around those broad categories. If you're going to store a lot of historical data for reporting, maybe you need a big data solution. But if you need real-time access to a current month of data, maybe you just store that in a relational database and then move the rest into a big data store later. If your relational database is going to ingest a large stream of data, maybe you need a queue that sits in front of the relational database that aggregates some of the data over, say, a 5-minute period, and then it only inserts that aggregated data into the relational database. If the data types that you're storing are object-based and you don't need a lot of reporting, maybe it's better to use a NoSQL database. Once you know the broad strokes and identify the larger pieces of how it's going to tie together, then you research which relational database would be good for your application based on feature sets and budget and things like vendor support. There really isn't a right and wrong answer here when choosing database vendors, but there's a good, better, and best for your specific use case. And if you're using the wrong type of database technology in the wrong way, you can really hurt your app going forward. Relational databases are not good substitute for big data store, and vice versa. Even if you're familiar with databases types, I would recommend you reading the book Designing Data Intensive Application. It's a really good book. It doesn't favor one specific database engine, but it talks about the broad strokes and how the database technologies all differ from each other. And when when is the right time to employ each strategy. By getting these higher perspectives on how to store and process data within your app, it will help you to select between all of the various services that AWS offers for storing your data. So let's actually talk about SQL or SQL, however you want to pronounce it first. By the way, guys, we're not going to be actually creating databases in this database series, or you could say sub-series. But we are going to be talking about the feature because it's really simple to actually implement a database or create one. Okay, so anyways, if you already have a relational database in like MySQL or Microsoft SQL, which I'm pretty sure most of you don't mess around with, you can always spin up an EC2 instance and install the database engine directly onto the server. If you're coming from an on-premise environment, this is probably how you already configure your servers, and AWS will let you replicate that same environment in the cloud. However, like your on-premise environment, you may not have responsibilities over the hardware anymore, but you're still responsible for all the configurations, the operating system updates, the database engine updates, the monitoring, setting up failover replication in case your database instance falls. And the list goes on and on and on. And like I said in the beginning, these are some of the things that I don't talk about in any of the videos, but you probably don't even think about them as well. So to help us out, AWS actually created a managed platform where you just give them your database and they do all of this for you. And this picture is getting a little bit boring, so I'm going to scroll down some so that way you can see what's going on down here. They managed all of the EC2 instances, the database backups, the database engine upgrades, even the failover replication. The service is called Relational Database Service, or RDS, and let's take a look at it right now. So if you go into services, go to RDS, type in RDS anyways, click on the first one, and I'm not going to be creating one, but we're going to click on Create Database. And this setup is actually pretty straightforward, like I said from the very beginning. And we're going to be creating a Postgres SQL cluster. So this is not exactly. It's similar to launching an EC2 instance. You select your t-shirt size down here. Now, about your t-shirt size, you can start small and increase the size of your instance as you scale up. The reason why is because you can't really scale back down once you already scaled up. So let's say I want the 4x large. I decide, hey, this is way too big and I don't really need this, so I want to scale down. You can't really do that. The way you have to do that is actually create a large instance and then duplicate all of the extra large or whatever we pick down here, the 4 extra large data into this large database, and then delete the 4x large and then reconfigure your application to connect to this database. It's really it's a hard thing. It's not really hard. It's just really tedious to do, and just make sure you click the right database in the beginning. So I would say start small and then scale up only when you need to. Now going down right here, if you select multi-AZ development option, RDS will create a second database instance for you in another availability zone within the same region and automatically configure the cluster for you. Now, if you're running a production database that needs a high uptime, I would highly recommend using multi-AZ, but it does double your cost, obviously. And I do have, I think over here, right here, here's a little, I guess, cost sheet of like how much of a development would cost. So for a T3 micro, it's going to cost 0.018 cents. But if you do multi-AZ, it's going to double that. So T3 micro now is 0.36, and this is per hour, by the way. So, I mean, like I said, they're not that expensive. They're actually reasonably priced. I mean, obviously down here, this shit gets insane. This is just like insane, but we don't need that. We need this, and not even that. We could probably go with it a little bit lower than that, but still. So even though the multi-AZ does create two clusters for this, in RDS and in your code, you will still only ever going to, God, why am I doing this? You're still only going to be connecting to the one of the cluster's endpoints. That's what I'm trying to say. Yeah. You're still only going to be connecting to one of the cluster's endpoints. So if you have this, if you have multi-AZ enabled and you need to make changes to your cluster, like provisioning more disk space or going to a larger instance, you'll likely not experience any downtime from these changes because RDS will make the changes on the secondary database first and then swap out the cluster and then make the changes in the primary database instance. You can always start in a single availability zone, and then as your uptime needs increase, turn on multi-AZ later and tell RDS to provision a cluster in the middle of the night so that you reduce the impact of your customers while it's performing these changes. Now, another thing to note is that if you choose to restore your database instance from the backups to a point in time in the past, RDS will create a second cluster for you. It won't restore the backups on top of your existing cluster, which is different than how restoring a database works from an on-premise environment. You can manually move data between your new cluster and your existing cluster and then just delete the new cluster when you're done with your repairs. Or if you want to use a new cluster as your main database endpoint, it will come up with a different database connection stream because it's a new cluster, obviously. So you'll have to change the database connections in your code to roll the entire cluster back to a point in time. So as you can see, RDS is actually pretty great, but you still have a few database administration tasks you have to perform, like keeping some monitors on read and write throughput. If the thought of this scares you or just bores you, it does bore me, you could look at Aurora. Let me actually pull that. I don't even have that on, so let me see. Amazon. Oh, I had it, damn it. Aurora, there it is. So Aurora works very similar to MySQL or Postgres from a developer's standpoint. However, it's a service where even more of the server management is handled by AWS, and it will even run in a serverless model where you don't even manage the instance at all, which is phenomenal. I messed around with Aurora. I really do love it just because honestly, you don't mess with anything. So if you really want to be hands off as much as possible in managing your MySQL or Postgres workloads, or you're just picking a relational database for a new project and you don't want to have to deal with anything even remotely close to the engine room, just look at Aurora. Honestly, it's a great one to use. So that is it for this video, guys. We just went over SQL databases. In the next video, we're going to go over MySQL. And by the way, over here, that's basically it, right? You got your VPC. We've already talked about VPCs. If you want to connect to another VPC, connect to another VPC. But that's basically it. Like, honestly, that's it. You just create your database and you're done. You have a database instance. And it'll tell you how to connect it just like it tells you how to connect it to your EC2 instance. But that was it, guys, for this video. MySQL, done. Next video, NoSQL. And we're going to get into that, how that works with AWS and all that stuff. So stay tuned for that, guys. And I thank you for your time that you spent with me watching this video. So I will see you in the next video, guys. Hope you subscribe, like the comment, like the video, and comment down below on what do you think about this. And if you actually want me to create a database, I will. It's just I don't want to. For databases, there isn't. I think there is a free tier. I'm not too sure. I don't think databases is a free tier. I'm not too sure. That's why I don't want to create it. Anyways, oh, here's a free tier one. Look at that. It's actually created. Let's see. Anyways, this is at the very end of the Postgres. Okay, password, master password. I'm gonna say password. Password. All right, and obviously it's going to select this one for you since it's a free tier. Storage type, yes. SSD. Allocated storage, yes. 20 gigabytes. Yep, this is a free version, so I would highly advise not to do any of that. And let's do it on my VPC demo. Password authentication, sure. If you want to do more than that, then you have IAM database, and then I'm not doing that. So let's create a database. Oh, we need 2 subnets. We still haven't. Oh, we could create a subnet. Now, remember, we're trying to do that second scenario thing. So I'm just default for right now. I'm just do default and create database. Never click on it. Database 1, and it's taking a few minutes. So after this is done, let's actually. Well, I'm not going to connect to it because this video is going to be longer than what it is. So I'll tell you how to connect to it, or show you where you could actually look for to connect to it. See, this is why I didn't want to create a database. It's been like, I don't know, 6-7 minutes, and it's still creating my database. Jesus. But anyways, I'll come back. All right, so I got the things that I actually needed, and here we go. This is how if you already know how to connect to a database using MySQL or whatever database platform you use, all you need is 2 things: your endpoint, which is this, and your port. This is basically it, obviously, and password. But this is basically it, and you already have it. It tells you right here and down here. That's in the connectivity and security section or tab, and that's it. That's how you connect to it. That's all you do. And if you already know how to do it, then yeah, go for it. But I'm actually going to be, once it's done, I'm going to delete it. But anyways, that is it. If you stay to the end, now you know how to connect to it. Thank you guys for watching this video. Bye.